Now let's go back to why there's an explanation for why water will evaporate. So we have water molecules, say in a glass. Well, the water molecules at the surface are being held by intermolecular forces. So here's a water molecule, and it's being held on the surface by intermolecular forces, but every once in a while a water molecule has enough energy to break free of the surface and go into the vapor phase. So now we have water in the gas phase. So even though water in the liquid phase is more stable at this pressure and temperature, there are some water molecules that manage to escape from the surface. And so there is a small vapor pressure of water above the liquid phase. Now, as you can imagine, if we increase the temperature as T increases, this vapor pressure of water should also increase because more of the water molecules have enough energy to break free from the surface and enter the gas phase. So when the vapor pressure is equal to the atmospheric pressure, or the pressure of the atmosphere pressing down on the beakers. I'll draw another diagram. So we have water here. We have atmospheric pressure being at the bottom of a sea of air, and we have the vapor pressure of the water vapor coming off the surface. When these two are equal, then we have reached the boiling point. So the temperature at which the vapor pressure is equal to the outside atmospheric pressure is defined as being the boiling point of that liquid. So at sea level, we are at 1 atmosphere pressure. So when the vapor pressure is equal to 1 atmosphere, the liquid will boil and that is called the normal boiling point. Normal meaning 1 atmosphere pressure for the vapor. This is sometimes referenced as T boiling point, the temperature for the boiling point. Now for water, that's 100 degrees centigrade. Now if we drew a graph of the vapor pressure of a liquid versus the temperature, we would see a curve that looks somewhat like this. So this is not linear, it's exponential in nature. And the vapor pressure of the vapor is proportional to E to the minus enthalpy of vaporization divided by R, the ideal gas constant, times the temperature. So here we see this exponential behavior. So we see that temperature is in the exponent, the enthalpy of vaporization is in the exponent. So as the temperature increases, the vapor pressure increases exponentially. So now next we'll look at how we can calculate vapor pressures versus temperature.